Okay, so this is the equation that we're going to be working with. This is Ogden's equation for determining the impact speed of a motorcycle based on the post-impact rotation of the target vehicle. Everything here other than g, which is just acceleration due to gravity, is going to have to be entered by the user. All of the parameter definitions are below here. So what I did was just screenshot the equation and then screenshot the definitions of the equation, and we'll just upload those to ChatGPT and give it a quick prompt and ask it to develop a Python program that will run this calculation for us, thereby having a tool that we can just put in our kit and open it when we need it, and also gives us, of course, the ability to perform sensitivity analyses in iterate so that we can figure out how different parameter values are going to affect our final outcome. So let's head over to ChatGPT. Okay, so I wrote this prompt beforehand so that I'm not wasting your time. But we're basically just saying, can we please create a Python script program to determine the impact speed of a motorcycle based on the attached equation and definitions? The only constant in the equation is g, which should be set at 32.17 feet per second squared. So we'll just create this for the imperial system at this point. Once you get success on the first go, then you can start adding a bunch of different options and even automatically performing sensitivity analyses quite easily. All other parameters, the user should be asked to enter the related value. Please let me know if you need anything else to accomplish this. So we're just going to add those photos. And once those are uploaded, we can hit go. So I'm using ChatGPT 4.0 here. It's going to come out very similar with 5. In 5, I've noticed that the Python scripts, it'll just give you a download file as opposed to writing out all the script, depending on what you prefer. The cool thing about Python is even if you don't have a big programming background, it's pretty easy to see what the mathematics are that are underlying everything. So it's very straightforward to QC. Small program here, so I'm just going to hit copy. To do this, you have to have Python installed. And I'll just put a link in the email to that. Very easy to do. So we're going to create a new text document. We'll call it Ogden underscore speed. We'll open that up, and then we will paste the code in there, hit save, close that out. The only thing we're going to need to do now is rename this file. And we're just going to put py instead of txt to tell it that it is a Python file. Okay, so Ogden speed underscore. So now what we're going to do is just run this in Python. So if you shift and then right click in here, then you can open in terminal. And this is what we'll get now. So we're going to tell it to run Python Ogden underscore speed.py. And then I must have messed up somehow. So let's see what it's actually called. I forgot the D in Ogden. So let me just change that name and go back to the terminal, Ogden underscore speed.py. All right, so now it's asking for the weight of the motorcycle. So I'm going to take an example from my motorcycle recon class, which you can see here. This is built in Excel. We're basically doing the same thing that we did with this big Excel file, not too brutal, but not too easy either. We're using Python to accomplish this, and with AI, you can really do it in a matter of minutes. So let's see if it works out. I'm going to put this on the other screen and use it to inform my values. Making sure to pay attention to the units. Here it's rotational friction coefficient. It's calling it one thing. So normally I would want that to be the coefficient of friction plus or multiplied by the efficiency factor. So coefficient of friction, something like 0.7. Efficiency factor in this case is 0.33. Multiplying those out, it's 231. And then the wheelbase of the car is 9.21. So then we get the impact velocity of the motorcycle is 58.9 and I actually put the wheelbase of the car in wrong. It's supposed to be 9.17, but I'm just going to shift it on my spreadsheet right now to 9.21 to match, and we get the same answer, 558.96 feet per second. So now we have a sweet little program here that we can use. You can copy this and just anytime you wanted to change a different value, be like, well, what if I'm using 100% of the rider's rate? So what if it's 700 pounds instead of 633 pounds? And you can just run this again. Of course, like I said before, you can do this. Let me use the real value here. So then it turns out to be 54 feet per second for the impact speed. So now that this is built, it's very easy to change units if you want to make metric units an option, if you want it to convert the final answer to miles per hour straight out of the gate, if you want it to allow you to give a range for each one of these parameters or a certain number of these parameters, you could do that. Really, one of the better uses for AI that I found in Recon the past few months can expedite some things and allow you to build mathematical equations or methodologies that would take a long time otherwise.